Okay, boleh dengar suara saya? Okay, boleh dengar suara saya? Okay, ada yang apa? Yang minta 5 minit Dia cakap macam apa? Nick Muhammad apa ni? Nick Muhammad Azwan, dia kata baru balik ke blog. Alright. Okay. Okay, kita ada Brian sini. Alright. Kita ada apa ni? Elvin. Brian, Azwan. Kita ada sekarang ni apa? Oh, Nestem Milu Besar. Oh, cantik kau punya nama. Ini kita juga Haikal, kita ada siapa lagi? Ya, okay, jadi tak apa, kita tunggu sekejap lagi ya. Actually untuk kelas ni ada 2 kelas, satu kelas lagi tu ada dia terlibat dengan kelas yang lain. So tak apa, dia akan tengok lepas ini ya. Alright, so untuk yang untuk yang tutorial 4 ni, untuk hari ni kita akan bincang mengenai tutorial 4. Okay. Dedak. Hai Dedak. And next, kita ada Muhammad Azwan. Genius ada di sini sebelah. Okay. Gus. Okay, jadi saya rasa kita terus ke apa kita punya perbincangan kita pada petang ini. So please look at the tutorial 4. Tutorial 4 is force, right? So sesetengah tajuk ni sudah kita kita ada juga sini. Okay, Sanisa. Hai Sanisa, CP21. Right, hai. Harap kamu sudah makan sudah minum. Right. Okay. Sasha pun ada sana. Hai Sasha. Sudah makan petang ya? Okay, so saya rasa saya akan terus pergi ke apa yang kita nak bincang pada petang ini. Tutorial 4 is force. Right? So you can refer to the tutorial question. Tutorial 4. First, we look at the objective question. Right? Saya cuba besarkan sikit Tak nampak. Sorry, besar sangat. Okay. So, question number 1. Question number 1, right? Newton first law. So Newton first law is consistent with the concept of, right? So we have a first Newton law, we have the second Newton law, and we have the third Newton law, right? So first Newton law is talk about the equilibrium force or total force or net force ataupun jumlah daya-daya yang bertindak dalam satu sistem is equal to 0, right? Net force or total force is equal to 0. So second Newton law is about the force, but you have a net force, meaning the net force is equal to 0. That's why if the net force is not is equal to 0, you can refer to the equation F is equal to ma. So for the second Newton law, because we have a net force here, daya bersih, kamu akan ada satu acceleration A. Okay, the third force is about the force, right here is FAB. AB is equal to FBA. This is about the action and reaction. So action, the force on by A on B, we have a force or reaction force from B to A. So this is a first, second, and third. So if look at the question number 1, we talk about the first law of motion. So first law of motion is about the net force is equal to 0. So here, net force is equal to 0. So if you look at the answer, A, B, C, D, it's not about the, we have the force, but we have for the first Newton law, so you must, the item inertia and mass, ataupun ada dua item yang kita bincang juga dalam first Newton law, iaitu berkaitan dengan inertia and mass. So apa itu inertia? Okay, so inertia ni merujuk kepada apa dia? Bagaimana kalau kita nak jelaskan first law, first law Newton juga, dia merujuk kepada satu jasad itu bila dalam keadaan diam, dia akan terus diam selagi tak ada daya bertindak, external force acts on the system. Ataupun dia akan bergerak dengan constant V, okay, jikalau dia tiada daya dual bertindak, so dia akan kekal dalam keadaan yang asal. Okay, itu sifat, okay, sesuatu jasad. Jadi dia merujuk kepada inertia, okay, or mass. Mass itu merujuk kepada ukuran bagi inertia. Meaning here kalau mass itu besar, inertia is also, the value of inertia is also proportional to the value of mass. Inertia tinggi, mass tinggi, inertia pun tinggi. Okay, kalau mass itu rendah, jasad itu dia punya mass dia kecil, automatic dia punya inertia pun kecil. That's why mass is ukuran of inertia. So what is the inertia? Okay, sifat sesuatu jasad itu dalam keadaan yang mengekalkan keadaan asal. So if you look at the question number 1, so first law of motion is about the inertia. Alright. Okay. Okay, so question number 2. And continue to question number 2. Right, here is number 2. So saya kecilkan sedikit. Right, here we have which of the following is not really example of action and reaction to which third Newton law? So the third Newton law, as I said earlier, third Newton law about the action and reaction. So maksudnya kat sini, kalau kita ada satu, okay, contohnya satu permukaan, kita kenakan satu force, external force acts on the surface. So maksudnya kita berikan force, katalah daripada daripada atas ke bawah. Jadi kalau ikut third Newton law, dia kata akan ada wujud satu daya or reaction force. Ya, same magnitude FF but opposite direction. Yang mana merah ni ke atas, masuk melibatkan dua permukaan, dua item kat sini, ada external force and ada permukaan kat sini. So if you look at the question number 2, it's not valid for example action and reaction, right? So okay, number A is force attraction between electron and proton. Yeah, we have two item here. Okay, from the electron to proton or proton to electron, and repulsive force between two parallel. So meaning here we have two parallel wire. And number C, the force attraction between two gas molecule passing through each other. So still we have two item here. So now is the answer number A, number B, number C is talk about the two item, okay, for the action and reaction. Okay, number D, the weight of satellite and centripetal for a KP satellite. So meaning here, if you look at the number D is talk about only the one item, single item here. So kalau kita tengok, kalau kita bincang mengenai third Newton law, dia mesti, kalau ni tadi kan, mesti ada the first item and the second item yang merujuk kepada dua item yang dikenakan di antara satu sama lain. So kalau number D ni dia cuma satellite saja. Okay, dia dalam satu item. So maksudnya kat sini dia tidak ataupun tidak boleh kaitkan ataupun tidak sah untuk kalau kita nak kaitkan dengan so the answer is D, right? Okay. So we go to the next question. Question number 3. Right? So number 3 here. Okay, tak boleh besarkan sekejap saya besarkan sedikit dulu. Oh, sekejap. Alright, so continue to question number 3. Okay, question number 3. Oh, sorry. Sorry padam dulu. Two wooden blocks Q and R. We have an object Q and R on mass 2 kg and the second mass is 1.5 kg respectively on the small stable or HN figure. So we have two objects. Of force 7 Newton acts on the block Q, right? On the block Q so that the both of the block accelerate together. So meaning we have two objects. When the external force 7 Newton acts on the object Q and R, the object Q and R accelerate together. And what is the acceleration? Not given by the question, right? Just say that this is a accelerate together. So what is the question asks you what is the force Q exert on R? Q exert and R here. Okay, so meaning here dia nak cari kat sini berapakah force yang dikenakan ke atas Q, the force Q on R, because we have a external force. External force ini kenakan daya ni ke atas Q dan Q akan kena ke atas R. And the next, kedua-dua objek ni akan bergerak. So bergerak pada acceleration A. So what is the acceleration A? So because we have a magnitude of mass and the force, if you look at the second Newton law, the net force is equal to ma. Kerana dia mesti ada daya bersih baru ada acceleration A. So now the force here is 7 Newton. 7 Newton. And the mass is a mass between 2 and 1.5. So here is mass here is a 3.5 kilogram. Right? And you can find the value of acceleration A. So if you calculate the acceleration A is this is 7. So we have so now if you use the calculator, this is 2 meter per second. So now both of object Q and R moving accelerations with acceleration 2 meter per second square. So the question asks you the force Q and R. So now here is what is the force here? What is the force QR? So the force of the QR still you have a equation mass time A, right? And the mass here, because the question asks you Q to R, so meaning this is force yang dikenakan Q kepada R. So refer to the mass here is refer to the mass Q, right? And the acceleration here, okay, acceleration here because moving with the same value for the both of item A and B, object A and B, 2 meter per second. So now here we have a mass of the QR is 2 kilogram, right? 2 kilogram, and the acceleration here is equal to, this is the question asked you is Q to Q exert on R, Q exert on R. So here we have a force, here is a mass of the R. So the force here is referred to the, because the force QR that make R moving acceleration 2 meter per second. And the force here is Q on R. So the mass here is not the mass Q. This is mass of the R. Sorry. So this is equal to, is given by the equation 1.5. So 1.5 of FQR is equal to 1.5 times 2 is equal to, use calculator here, is 3, right? So 3 Newton. So if you look at the answer given is 3 is B, right? B. Okay, so we go to the next question, question number 4. Okay, number 4 here is, if then there is not net force acting on object, what is mean, right? Maksudnya here, this is refer to the first Newton law. So meaning here we have a no net force, or the net force or total force is equal to 0, or the net force is equal to 0. Daya bersih bersama dengan kosong. Okay. So ini hanya boleh berlaku jikalau objek itu pada object at the rest, yes, correct. Object at constant velocity, yes, because F is equal to MA. If constant velocity here, A is equal to 0, so the F is equal to 0. So relate to the net force is equal to no net force, right? Acceleration 0, yeah, of course, that's correct. All above, yeah, the answer is A, B, and C. The answer for A, B, and C is referred to the process or situation where the net force or no net force or net force is equal to 0. Right, class? We go to the next question. Okay, so the next question here, okay, a body of mass is inclined plane of theta horizontal, the body move plane is constant velocity when horizontal force Fx on. Okay, just look at to the diagram here, right? So the question you can, okay, the question asks you to calculate the, the question asks you to calculate the, right, saya buang dulu yang ni, senang kita nak tulis nanti Okay, so now the question asks you for the number 4 here is what is the, is it the, I think the friction force, right? Because the object on the inclined plane with the angle theta, so we have external force F. So what is the friction force? Because the object, the force acts on the object and the object moving to downward here. But the force here is not the horizontal, so you must resolve to the, you can use the, okay, equation, the triangle here, this is force here, right? And this is theta, this is also angle theta. So resolve, this is force, okay. Saya rasa lebih senang kalau kita buat free body diagram dulu so saya lebih jelas. So, you draw the free body diagram first. right? So the first we have a weak force, and we have a normal force direction. This is N, and we have a this is force, force, external force, and because the object moving upward, so we have a friction force here. So if you draw the free body diagram here, so we have a normal force here. So we have a sorry, this is not the force X on the object, right? So we have a, and we have a friction, so we have a weak force W, and we have another force here, so here, right? Okay, this is external force F. So the question asks you to calculate the okay, friction force. Okay, Shaharia, is it compulsory to draw the free body diagram? It depends on the question. Okay, tapi kalau macam saya sendiri, untuk kita nampak okay, jelas the total force, because kat sini kita kena leraikan dia kepada okay, paksi Y, and you can resolve to the Y, X and Y axis. So lebih senang kita nampak use of free body diagram. But if the question not ask you to draw the free body diagram, so no need, right? Bergantung kepada soalan yang diberikan kepada kamu lah. That's why kamu kena baca soalan betul-betul. Tapi kalau melibatkan chapter 4 ni, biasanya penyelesaian resolving vector berkaitan dengan force, biasanya kita akan rujuk tunjuk kepada free body diagram. Apatah lagi jika kalau soalan tu tanya ataupun dia first question, biasanya draw free body diagram. So kamu kena lukis lah. Alright. Okay, class. So now the question asks you to calculate the force, the frictional force, because the object moving upward here, right? Moving upward here. So friction direction to downward. So we have a net force direction to upward because of object moving upward. Okay, ada setengah pelajar tu dia guna konsep resolve the force here to the Y and X axis. Okay, tak ada masalah. Tapi sini saya terus ya, oleh kerana jasad ini bergerak ke atas, dia perlu mengatasi daya ke bawah. Okay, so daya ke bawah yang kita nampak jelas sini adalah force, friction force. So we have a net force ke atas F, right? Tetapi force kat sini dia berasal daripada merujuk kepada force, external force. Tapi external force ni arah dia ke sana. Arahnya tu ke arah sini. So kamu kena resolve selari dengan arah friction. Okay, supaya daya ke atas F yang ni F yang ni tolak dengan friction ke bawah. So yang ni kamu kena resolve F ini kepada ini saya katakan tadi ni. Okay, kalau saya padam kat sini saya padam kat sini, right? Jadi kita nak resolve ni nak resolve force ini kepada arah X, arah selari dengan pergeseran. So kita pakai segitiga ni. So this is theta, this is also theta. So kat sini force kat sini adalah, because this is adjacent, this is F cos theta. So F kat sini yang menyebabkan jasad ini naik ke atas adalah F cos theta. So this is net force, kita nak cari net force. Jadi F cos theta minus, pertama kita ada juga friction ke bawah. Untuk bergerak ke atas dia perlu atasi friction ke bawah. Dia perlu minus friction. Satu lagi kamu ada juga daya berat yang menyebabkan jasad ini nak turun ke bawah kan. Jasad ini kalau dalam keadaan condong dia akan turun ke bawah. So ada juga force yang ke arah bawah perlu diatasi oleh friction force ini. Iaitu kita guna segitiga yang ni, sini theta, this is also theta. So force ke arah sini ke arah sini, force ke arah sini yang menyebabkan objek ni jatuh ke bawah. Okay, saya tulis kat sini adalah kita boleh gunakan, because this is weak force, this is W is equal to mg. Okay, kalau saya lukis segitiga kat sini, saya ambil sini. So kita ada weak force ini W or is equal to mg. So kita buat segitiga kat sini. So this is theta, this is theta. So force kat sini opposite, so this is mg sin theta direction. Force yang kat sini sama arah dengan friction ke bawah, perlu dua daya ni, 1 dan 2 ni perlu diatasi oleh force yang kamu tolak ke atas. So first minus friction, satu lagi kamu kena minus mg sin theta. Mg sin theta. Right? And saya rasa soalan ini kalau kita tengok kalau saya naik ke atas ni dia akan hilang semua ni. Okay. Saya rasa is equal to 0 is equal to 0, this is constant velocity. Right? So dia nak cari friction force. So friction force pindah saja ke sana. So kita akan dapat okay, pindah saja ke sana ya. Sorry because F kita pindah F F ke sana. Okay, so dia nak cari friction force kan? Dia nak cari friction force. So friction force is equal to F cos theta, this is minus mg sin theta. So inilah friction force. Okay, saya padan yang ni Jadi F cos theta mg sin theta. So ini this is the answer is C. Okay class. Okay, question number 5. So finish objective question. So we continue to question number subjective question number 1, right? So question number 1 is draw free below is figure identify the force and body situation. Okay, saya rasa soalan ni dia nak suruh kamu lukis free body diagram So how many force X on the system here? So saya lukis kat sini Okay, saya potong dulu yang ni, yang A. So first number A. So we have the direction to downward. So meaning we have a rough surface. Rough surface meaning we have a friction force F. Okay, we have a weight force direction to the downward, and we have a normal force. So now if you draw the free body diagram, so we have a make sure ini bukan free body diagram. Ada pelajar dia anggap ini free body diagram. So first kalau dalam exam tu kamu kena guna pembaris mesti lurus. Saya buat sini tangan saya ni tak lurus sepatutnya kamu guna pembaris. So mesti lurus and tulis N, mesti ada arrow. Lepas tu friction ke sana, ke atas This is friction. And we have a straight forward, downward. We have a weight force. So make sure rajah ini besar dan mesti guna pembaris, mesti lurus. This is vector. Okay. So we go to the second question and number B. So how you draw you can draw the free body diagram here. So consider how many force. So this is okay, because the object pulled with the external force X, meaning the direction of the object A ke kiri and object B tu ke atas. So if you have the two item here, so kita separate you separate the free body diagram with the two here. The first diagram is for the object A. So how many force X on the object A? So seperti biasa we have a weight force and we have a normal force upward, and also we have the external force here. Okay, F, and because this is rough surface, because object moving to the left, so meaning we have a friction force, and the object connecting to the string. Bila kamu tarik objek ini ke kiri, string akan tegang ke arah kanan. So now if you draw the free body diagram here, so how many force X on object A? So we have W, friction, T tension, right? And N is a normal force, and force F here is a external force. So now if you draw the free body diagram, so we have a external force F. Okay, make sure you guna pembaris, mesti lurus So ini saya cuma lakaran saja normal force, and we have the weight force direction straight to downward, and we have to the left we have the two force. The first is a friction force, and the second force is refer to the tension of the string. So this is the free body diagram for the object A. For the object B, we have only two, because we have object, we have the weight force direction downward and connected to the string. So of course the tension of the string direction to upward. So if you draw the free body diagram here, so we have a tension and we have the weight force. So the two force X on the object B. Okay, so continue to the figure C. So figure C here, we have two items here. We have M1 and M2 connected to the string, and we have the pulley system here. And direction to for M1 upward and M2. Let's say this is M2 here. So now we have the two items, so separate to the second two part. The first part refer to the M1. For the M1, we have a weak force W, and we have the tension of the string to upward. So free body diagram for the M1 here is we have a tension of the string, and we have a weak force W. And for the M2 here, for the M2 free body diagram here, also we have a weak force direction to downward and connected to the string, so meaning we have a T. So now free body diagram here, we have a W and T, right? W and T, right? So this is number one, finish. Continue to the question number 2, right? Okay, so number 2, based on the figure 4.6 and 4.7, so you have a two figure here, and draw free body diagram. So meaning here, the question asks you to draw a free body diagram. So if you look at the figure 4.6, we have an object on the rough surface and direction external force to the right. Okay, daya ini ke arah kanan, automatic rough surface, friction to ke arah kiri, and the object is on the table. Let's say on the table, so we have the weak force direction to downward, and we have a normal force direction to the upward. So meaning if you draw the free body diagram here, so we have the how many force? 1, 2, 3, 4. The first force is normal force. So make sure you use a ruler to draw the direction of the vector for the each force. Okay, pastikan dia lurus kan, friction, and this is a W. So this is a free body diagram, right? For the object on the rough table or rough surface, right? Okay, continue to the number 2B. Okay, number 2B, we have two object. Let's say this is object A and this is object B. So now the object moving to the right, bergerak ke arah kanan, and object A and object B connected to the string, and we have the external force F. So now first is refer to the object A. So how do you can draw the free body diagram? So what is the number of force X on the object A? So the first is a weak force, and the second is a normal force direction to the upward. And this is smooth table, so meaning we have no friction force, right? But connected to the string here, connected to the string because force here to the direction of the object to the right, so or the external force X on the right direction, so meaning the tension is to the left, right? To the left. So here the free body diagram here is the first is this is for A, normal force, and we have a W, and we have a tension of the string here. So this is the tension, this is for the N, and this is for the N. Sorry, this is for the weak force direction to downward. All right. So continue to the object B. So object B here we have a object B connected to the string and the force, external force F. Also B have a normal force and weak force, and this is smooth table, so meaning no friction, no need consider the friction. So here what can to draw the free body diagram for object B, so you have a normal force, and here is normal force, and we have W here, direction to the downward, and we have a external force F, and the string here, because the force pull the object B to the right, so the tension of the string to the left. So this is free body diagram for the object B. right? Right? Okay. Okay. So, okay. Okay. Continue to question number 3, right? Number 3, right? Okay. Number 3, you have this calculation. Okay. Look at the question number 3, yeah. Okay, students. Question number 3 here. So, saya buang dulu yang ni, ya. 3 kilogram, 30 kilogram block is placed on an inclined plane with the angle 20 degree with the horizontal, as shown in figure 4.8. The coefficient of kinetic friction between the block and the inclined plane is 0.2, right? So this is because the direction of the object to downward, so meaning here we have a friction force on the direction to the upward, and draw free body diagram. So yeah, free body diagram. So first we have a wake force, we have a normal force, and we have the friction force here. So if you draw the free body diagram, so we have a friction force here, we have a normal force here, this is normal force, and we have a wake force straight forward to the center of the earth, right? This is a free body diagram, question number A. Okay, number B, the question asks you to calculate the friction force, right? Friction force or FK. So how you can calculate the friction force here? Sorry, potong dulu ya ni. Right. Okay. So to calculate the friction force here, so the first is because the object moving downward. So meaning we have a net force here. We have a daya bersih turun ke bawah. So to moving object to the downward, so you must overcome the friction force here, right? So tadi kita dah tengok tadi kan, so we have a wake force direction to the, okay, sorry saya potong dulu yang ni, so senang sikit ganggu sini. So okay, so this is a wake force W, and we have a normal force here, and okay, saya ni macam saya padam dulu sini, so nampak lebih clear ya, right? Okay. So we have a wake force direction straight, and we have a normal force here. Okay, so if you draw the triangle here, say the triangle here, right? The triangle here, so this is 90 degree. So now, kinetic friction, because the object moving downward, so meaning we have the let's say the net force, daya bersih, right, ke bawah. So daya bersih ni untuk objek yang turun ke bawah must overcome the friction force because this is a rough surface, right? Rough surface. So now to calculate the value of the kinetic friction or Fk here, right? Kita tahu rumus untuk kinetic friction or friction here is a nu time normal force N, right? Okay, so now because the coefficient is given by the question is 0.2, so the problem here is what is the normal force. So if you look at the diagram here, the normal force here, you can, this is what is the normal force. So this is what is the value of the normal force. So normal force here, because the object is not moving to the direction to the normal end or direction, let's say this is a kita pakai sini katalah sini y, okay, sini katalah kita pakai sini x. The object is not moving on the y axis, dia hanya menggelunsur pada arah x. So meaning here total n daya pada paksi y kat sini merujuk kepada n sini adalah kosong, iaitu daya ke atas sama dengan daya ke bawah. That's why kita boleh ambil sini n kat sini sama juga n dengan di sini. Right? N saya buat tanda kat sini merujuk kepada n yang kita guna segitiga kat sini. So now to calculate the value of magnitude value of n here, so you consider the total force for the the system here. So n, okay, daya ke atas tolak dengan daya ke bawah, tapi dia sama because kita pakai vektor yang sama ya. So untuk cari n kat sini, because sini theta, this is 20, this is also 20. Right? This is 20, saya tak nampak, this is also 20 degree. So now because to find that this is adjacent, so you can use this is a hypotenuse. So here is a merujuk kepada, because W is equal to mg, so here is the adjacent here is a mg adjacent, use a cos 20. So daya ke atas tolak daya ke bawah, daya ke atas n minus daya ke bawah, this is a here, right? mg cos 20, dan dia tidak bergerak ke atas ke bawah, that's why is equal to 0, or the total net force is equal to 0 untuk arah y. Kita anggap ini arah y, ataupun daya ke atas sama dengan daya ke bawah. So now you can find the value of n is equal to mg cos 20. Right? So now you can use the equation here. So now here this is value of n. So saya tulis kat sini tulis balik kat sini. So kinetic friction is equal to nu is a 0.2 and the n here is a mg cos 20. So now mass given is a 30 kilogram, right? And the g constant 9.81 and cos 20. So you can use the calculator here. So 0.2 times 30 times 9.81 cos 20. So this is equal to, it's around 25.31 Newton. Right? Kamu boleh kira sendirilah. So ini jawapan yang dia bagi Right? So the friction force. Okay, class. So we continue to the question number 4. Right? Next question is question number 4. Okay, class, question number 4. Distinguish between static friction and kinetic friction. Right? So what is the static friction? So what is the kinetic friction? So kalau kita tengok kat sini, friction itu sendiri dia merujuk kepada apa? Dia merujuk kepada oppose ataupun daya yang menentang, force oppose the relative motion between the two surface. So maksudnya kalau kita ada satu jasad, okay, bergerak ke arah kanan, so friction itu bergerak ke arah kiri. Yang keduanya adalah static friction dengan kinetic friction ini. Kalau kita tengok static friction dia ataupun Fs dia hanya bertindak pada masa bilah, pada masa objek itu tidak bergerak, static. Manakala kalau Fk merujuk kepada kinetic friction ataupun friction yang merujuk kepada objek itu sedang bergerak pada katalah pada hal laju v. Okey, pada acceleration a contohnya. Jadi kita boleh katakan static friction masa jasad itu stationary, tak bergerak. Okey, stationary. Okay, kalau yang kinetic friction, daya geseran yang bertindak semasa jasad itu sedang bergerak ataupun moving. Alright, so this is how you can differentiate between the static and kinetic friction. So look at the number 4b. A 3 kilogram cube is placed on the rough plane as shown in figure. The plane is slowly tilted until the cube start move from the rest. This occur when the angle inclination is 25. So the calculate static frictional force. So meaning here jasa ini asalnya mungkin dalam keadaan horizontal. Lepas tu the slowly tile itu tile anti cube start move. Maksudnya kita angkat dia punya landasan ini ke atas. Makin condong. Dan seterusnya pada satu angle 25 ini, okay, the object, right, okay, the cube start to move. Maksudnya dia belum bergerak lagi, dia baru nak bermula untuk bergerak. So maksudnya masih lagi friction yang ada kat sini adalah static friction lah. Dia belum bergerak, sejurus sebelum bergerak. So now, to find the answer, the question as you calculate the static frictional force. So meaning here this is a Fs, right? So now to calculate the static frictional force, so first is you must draw the free body diagram ataupun daya bertindak kat sini weight force, and this is a normal force, and we have a friction here. Static friction, right? Fs. Or if you draw the free body diagram here, so we have a normal force, we have a friction force, and we have a weak force. So now here we have a three force. So if you look at the diagram here, object 3 kilogram start moving to downward when the weak force yang menyebabkan jasad ini mau bermula untuk turun ke bawah. So mesti ada force kat sini. So force ini datang daripada mana? So kita ambil force yang datang di sini. This is also force. So kita boleh guna kat sini segitiga kat sini. This is 90 degree. So the weak force is a mg. So the force here, this is 25. This is also theta 25. So kita boleh cari this is opposite. Kita guna segitiga kat sini. So here is a F. Okay, saya tulis kat sini. F here is equal to resolve mg to the, let's say this is x axis. So kalau kita pakai paksi kat sini, this is y axis. So here this is a x axis. So here this is a mg opposite, so we have a mg sin theta. Okay, mg sin theta here, the direction here. So daya inilah yang menyebabkan jasad ini turun ke bawah. Tapi untuk dia mulai turun ke bawah, start moving to downward, so the force here must overcome friction force here or static friction here or Fs, daya ke atas. So kalau kita buat dalam bentuk persamaan kat sini, so daya ke bawah iaitu mg, okay, saya tulis kat sini untuk sini, daya ke bawah this is mg sin theta mg sin theta minus friction force ke atas ataupun static Fs, okay, is equal to 0. Why is equal to 0? Because pada masa ini dia masih tidak bergerak. So this is actually is equal to MA. Tapi dia tak bergerak, so this is why it is equal to A is equal to 0. This is why M times 0 is 0. So now static frictional force here, so Fs here is equal to mg sin theta. So here mass is 3 kilogram, g is constant 9.81, and the theta here is a sine 25 degree. So now you can find the value of the, use a calculator. So you can use, this is mass here, 23 times 9.81 sine 25 is 0.4 to 6, right? So now this is equal to 12.44 Newton. This is a frictional force. All right, this is question number 4B. So class, continue to next question. Question number 5, right? Question number 5. Sekarang ni pun dah hampir 1 jam. Baru nombor 5. Okay, kita ada 5 soalan lagi. So tidak apa. Alhang kita pergi. Okay. Okay, kalau ada soalan tu boleh tanya dekat situ, dekat ruangan tu ya. Ruangan chat itu. Right? Siapa yang ada kelas jam 3 tidak apa, boleh pergi kelas. And then yang student yang free jam 3 tu dia kena tengok ni kan. Untuk kelas untuk ni. Okay, question number 5. Three force as shown in figure where the F1 20 Newton, where is 1, this is 20 Newton. And F2, so where is F2 here? We have F2 here is 40 Newton. And we have the F3 here, this is 30 Newton. Calculate the magnitude and direction of a resultant force. So umpama ya, kalau saya lukis situasi ni, kamu ada satu jasad, kita di atas meja. So jasad ini akan dikenakan oleh 3 daya. Satu, jasad ini ditarik ke atas, okay, external force 20 Newton. Satu ditarik ke sana 40 Newton. Satu lagi ditarik ke bawah 30 Newton. Jadi soalan ni kata, apa akan jadi kepada jasad ini selepas dikenakan 3 daya? Ataupun katalah kamu kan berdiri kat sini, kepala kamu ditarik ke atas 20, lepas tu telinga kamu ditarik 40, tangan kamu ditarik ke bawah 30. Apa akan jadi kepada badan kamu selepas dikenakan 3 daya? Itu maksudnya resultant force itu. Kamu akan pergi ke mana? So what happened to the object when the three force, as shown in figure 4.0 here, after the three force acts on the system. So itu maksud dia. So jadi kat sini kalau kita kalau kita nak tengok dia kat sini, right? Maksudnya kat sini 3 daya tapi pada arah-arah yang bertangan. Untuk kes sini kita guna macam resolving vector. Nak cari resultant, so umpama kita leraikan 3 daya ni pada arah x axis, right? And the second resolve to the y axis, right? Leraikan. So first is F1. F1 is on the y axis. So x axis is equal to 0. So the first is a up direction to the upward. So meaning we have a 20. Okay. And the second is a F2. F2 here for 40 Newton and the angle 45. So now you can resolve to the y axis for the F2 here, direction to upward. So we have a positive, but this is opposite to angle 45. So here we have a 40 sine 45. Okay. F3 F3 direction to the downward. So downward. So resolve F3 to downward here. So F3y direction to downward opposite. So we have also this is negative. Okay, negative 30 opposite. This is sine 45, and the object is not moving. Sorry, is this is for the y axis. So here, so this is for the y axis, and the next is a this is Fy, right? Okay, this is Fy. And the Fx here, because F1 is equal to 0, no for the F1 for the x-axis, so B here, so with direction to the right, so we have a Fx, so saya tulis kat sini right, so we have a first 40, so 40 resolve to the x-axis here, so we have 40 cos 45, And the second 30 Newton F3 resolved to the X here. So we have also positive. This is a 30 cos 45. And this is equal to Fx. Right? This is referred to the you have two force direction to the Fx and two direction to the Fy. So seterusnya kamu kira lah total berapa yang ni, tambah, masukkan nilai, okay, tekan kalkulator. So kamu akan dapat Fy dan kamu akan dapat total bagi Fx. So the question asks you to calculate the resultant. So resultant here, saya buat kat sini formula saja, resultant ataupun daya bersih pun boleh ya. Apa akan jadi kepada jasad ini selepas 3 daya bertindak or resultant force? Kamu ambil saja square root 2, ambil Fy square, nilai ni kamu tambah square, and plus Fx square, Fx tambah and square. So kamu akan dapat sini ya. So kalau saya guna, this is 40 cos 45 plus cos 45 so Fx, so Fx is equal to 49.50 Newton, and Fy here 20 plus 40 sin 45 minus 13, so this is equal to Fy is equal to 27.07. So here for Fx here is equal to Fx is equal to 49.50 and Fy is equal to 27.07. This is square plus, and the next square root 2 here. So this is 56.42 Newton, right? This is the resultant force. So direction, so meaning direction here, you can use the tangent theta is equal to Fy divided by Fx. So theta here, direction referred to the theta is inverse tangent Fy divided by Fx. Okay, so the Fy here is 27.07 and the Fx here is 49.50 Newton. So you can use the calculator here. So the theta is equal to, right, so you can use the theta is 28.67 degree. Alright class, the theta here maksudnya kat sini kamu ada 20 Newton, sini 40, sini 30 biasanya. Okay, theta is positive, tangent positive, maksudnya angle kawasan ni lah kan. Sorry, this is 40 this is 30. So saya ingat dia kawasan sini. Kalau kita lukis the force here, iaitu berapa tadi kita dapat sini 56. This is daya bersih 0.42 Newton. Okay, lepas tu angle dia kat sini adalah 20. This is direction of the net force, daya bersih 7. Pada sekuan yang pertama, first quadrant. Okay, class, question number 5. Okay, so continue to the question number 6, right? Continue to the question number 6 here. Okay, number 6, right? Okay, number 6 here. Okay, so the first question is the state first Newton law. So first Newton law is kalau kita kata, kalau di sini rumusnya total equilibrium force, total force is equal to 0, is equal to net force, daya bersih is equal to 0. Ataupun kalau kita boleh katakan satu jasad itu, kalau dia dalam keadaan yang diam di atas meja, dia akan selama-lamanya akan diam. Ataupun kalau dia bergerak dengan V constant, laju yang constant, selama-lamanya dia akan bergerak dengan constant V selagi tiada dari luar yang bertindak ke atas sistem. Okay, so the first Newton law state that an object at the rest will remain at the rest or continue moving uniform velocity unless ataupun tak, sehingga tak ada daya luar yang bertindak. Jika ada daya luar, hukum first Newton law tu tidak boleh diguna pakai. Okay, define of mass. Actually mass ini yang unit kita pakai kilogram itu, the mass is the ukuran untuk kita nak mengukur inertia. Alright, the mass is defined as a measure of resistance of objects. Maksudnya untuk kita kita tahu inertia kalau jasad itu jisim dia besar, inertia besar. Susah untuk kita gerakkan kalau jasad itu besar. Okay, kalau jasad itu kecil, lagi senang untuk kita gerakkan dia, merujuk kepada inertia tu kecil. Right? So number C, define equilibrium particle. So maksudnya kat sini, equilibrium particle ni merujuk kepada jumlah daya-daya or total force is equal to 0. Seperti kat sini tadilah. Okay, jumlah daya-daya walaupun ada 1, ada 2, ada 3, ada 4, jikalau jumlah daya itu sama dengan kosong, maksudnya dia akan berada dalam keseimbangan ataupun equilibrium. So this is number 6C. So continue to the number D. Okay. So the number D here, calculate the magnitude and direction of a force that's balance 3 force on the particle A as shown in figure. So soalan ni saya rasa lebih kurang sama macam soalan tadi juga. So the first is you must resolve the force to the x-axis. Okay. Okay. And the second force is okay, sekejap Okay, so the first is resolve to the x-axis, and the next is resolve 3 force to the y-axis, right? Okay, for the x-axis, so the F1 here resolve, so kita boleh pakai segitiga kat sini. So this is kita boleh pakai segitiga kat sini. Yang ni pun kita boleh pakai segitiga kat sini. So resolve macam biasa, kemudian kita dah belajar ya. So F1 resolve to the X, so this is angle 55, so here is a 12 cos 55 because direction to the right, so positive. For the F2 direction, for the x-axis to the left, so you must have a negative sign. So 20 here, resolve here to the X, this is a cos 30, right? Okay, and for the F3, resolve to the X here, because also to the left, also negative, 30 cos 45 degree. So this is equal to 0, because this is a balance force. Maksudnya jasad ini tidak bergerak. Right? Negative magnitude is force is balance 3 force. Okay. Right? So, and the next is Fy. So, same process here, 12 direction to the upwards, because this is opposite, this is Fy. Fy here, so 12 sine 55. Okay, for the F2, also to the upward here. So, we have a positive. Force is a 20. So, 20. This is a Fy, right? Sine 30, and here is direction to the downward. So we have a negative sign here. Magnitude force 30 sine 45. Also is equal to 0 because equilibrium, right? So you can use the calculator here. So for the F, X here, right? use 12 cos 45 minus 20 cos 60. So this is okay, 31.6 Newton. And the y-axis or Fy here is equal to 1265 sine 30 minus 35. Y is equal to 1.37 Newton. Right? So this is Fy, this is Fx. So now magnitude, balance force or resultant force or force is net force ya. So macam biasa kita pakai Fx square plus Fy square. So now here Fx is 31.6 and the Fy is 1.37 Newton. So you can use the calculator here, 31 square, right? Square, and the square root 2. So the net force is equal to 31.6 Newton. All right. You can use your own calculator, right? Yeah. And direction. So direction, you can use the theta or inverse tangent theta is Fy divided by Fx, and Fy is 1.37 and Fx 31.6. So theta, the final answer is 2.48 degree. Right? Theta. Okay, finish question number 6. Continue to question number 7. Okay, we have another 3 question. Okay, 3 o'clock 1 hours. Okay, tabah bertahan lagi kat sini. So sama juga ya, kalau ada apa-apa soalan yang ada dekat online sekarang ni, so boleh bertanya ya. So number 7A, state the second Newton law. So the second Newton law case is the force is proportional to the rate change of momentum. So ada pelajar dia kata kalau second Newton law is F is equal to ma, bukan ya? Second Newton law, this is F is equal to ma itu adalah produk daripada second law. Asalnya second Newton law is merujuk kepada perkaitan force dengan change P is momentum. Maksudnya P kat sini adalah perubahan momentum akhir tolak dengan momentum awal, and dt is divided by time t. So if you look at the equation here, use the equation here, force is equal to mv minus mu divided by t here. So you can use the m here because the same value. So use v and u. So v minus u and divided by time t, right? And v minus u divided by t, this is equal to acceleration. So now this is equal to ma. That's why F is equal to ma here is the product of the second Newton law. Okay, all right class. So we go to the next question, number 7B. Okay, 7B here, 7B. So we have a diagram. So first we read the question first. A 2 kilogram object is placed on the rough plane, inclined to 30 degrees with the horizontal as shown in figure. It releases from the rest and accelerate 4 meters per second. Okay, calculate the frictional force. So, so if you look at the diagram here, so first is I write the information given by the question. Object is 2 kilogram at a day. So here we have a, okay, so we have a mass is a 2 kilogram here. And the next we have a, okay, look at that. Acceleration, yeah, acceleration is 4, and release from the rest, meaning start with initial velocity 0. Calculate the frictional Okay, frictional force. Okay, this is 7B, right? Sorry, 7B. Oh, sorry, this is not the number A, 7B. Okay, calculate the frictional force. Okay, frictional force. So the object here moving downward, right? Moving downward, accelerate with the, okay, bergerak ke bawah pada pecutan, okay, 4 meter, 4 meter per second. And this is raw surface, so we have a frictional force or kinetic frictional force. And yeah, so what is the value of the Fk here? So now seperti biasa untuk case ini kita consider dulu free body diagram. This is wake force and this is a normal force, and we have the wake force. Wake force direction parallel to the frictional force here, ya. Yang menyebabkan dia turun ke bawah. So berapakah F kat sini? This is, let's say this is daya bersih. Okay, kita nak mencari daya bersih kat sini berapa? We have a net force. Why we have a net force? Because we have a acceleration here. So untuk jasad ini turun ke bawah, dia perlu mengatasi daya ke atas. Daya ke atas kita cuma ada daya gesiran. So daya ke bawah kat sini kita boleh pakai segitiga kat sini seperti biasa. So kita boleh gunakan warna merah ni, W yang ke bawah ni, W iaitu is equal to mg. So saya besarkan segitiga kat sini. So F kat sini berapa? Yang menyebabkan dia ni sama arah kat sini, F net saya tulis kat sini. So F kat sini kita gunakan resolve segitiga ni menjadi mg sin 30 degree. Okay, sini tak nampak sekali. Saya padam balik sini supaya lebih jelas sorry. Itu penerangan tadi. So maksudnya kat sini jasad ini turun ke bawah. Mesti ada daya bersih kat sini. Apa yang menyebabkan force ini ada? Kerana ada daya berat. Tetapi dia tak jatuh ke bawah. Yang jatuh ke bawah cuma wake force. Okay. So kita ada juga normal force macam biasa. Dan dia rough surface. So mesti ada friction force ke arah sana. Jadi sekarang ni kita nak cari berapakah F yang menyebabkan dia turun ke bawah. So kita pakai segitiga di sini. Right. So 90 degree. So sini 30. This is also 30 degree. So kita nak cari berapa force kat sini. Sama dengan force di sini lah ni. Yang menyebabkan jasad ini tergolek jatuh ke bawah. Untuk dia jatuh ke bawah, dia terpaksa overcome friction force yang ke atas. So meaning here, force kat sini adalah segitiga. Because W is equal to mg. So force kat sini adalah mg sin theta. Jadi force kat sini pun sama dengan yang jatuh ke bawah ni adalah mg sin theta. Jadi kalau kita buat persamaan, okay, daya bersih yang menyebabkan daya bersih ke bawah ni, terhasilnya daya bersih itu mesti daya ke bawah iaitu mg sin theta minus friction force ke atas, friction force, okay, is equal to, dia bukan sama kosong kerana dia acceleration kan, dia bagi sini 4, so acceleration is equal to 4 and the mass given is 2 kilogram, 2, and this is 2, G is 9.8, 1, and the theta here is 30, right? So you can find the value of the kinetic frictional force, or frictional force is equal to 2 times 9.81 times sin 30, and this is minus 2 times 4 is 8. So Fk is 1.81 Newton. Okay, class? Frictional force here. Okay, so continue. Next question. Next question, question number 8. So we have a pulley system here. Alright, pulley system, sorry. The system, okay. Okay, so a 4 kilogram block A on the rough surface 30 degree. Inclined plane is connected free hanging 1 kilogram block B. Ya. Tengok sini rajah ni Jasad ini kita ada jasad A dan ini jasad B Jadi dia akan bergerak ke bawah. So ada acceleration lah. Sini pun ada acceleration ke bawah juga Okay. When the object released from the rest, object A is slide down inclined plane with a friction. So this is thrust surface. So object A, here we have a friction force given is 6 Newton. Oh, dia bagi nilai friction force 6 Newton. Okay. Calculate acceleration of the object. So first kamu perlu tahu kalau dia nak cari acceleration untuk kedua-dua jasad ini adalah sama. Okay, ingat kedua-dua jasad adalah sama. Sama juga tension because dia jatuh ke bawah jadi tension itu ke arah sana because overcome friction ke atas dan jasad ini ada berat, so dia ada weight force dan dia ada tension mesti tegan ke atas. So sama juga kat sini, dia ada weight force ke bawah and we have a normal force ke atas So, kalau kita nak buat free body diagram, yang A ni free body diagram, yang A tu maksudnya, so kita ada apa? Normal force, kita ada tension T, dan kita ada friction force, dan kita ada weight force W. For the object B, normal free body diagram, kita ada T, ada 2 saja kan? And we have a W to ke bawah. So this is free body diagram for the object A and this is for the object B. But the question asks you to calculate the acceleration here. So what is the acceleration? Tapi acceleration untuk dua-dua jasad ini, untuk case ini adalah sama. Okay, sama juga T kat sini, sama dengan T di sini. Because dia disambung dengan tali yang sama. Okay, now to calculate the acceleration, biasanya kalau kita nak tahu satu item, biasanya dua jasad ini dia akan menghasilkan, jasad A akan menghasilkan satu persamaan first equation and jasad B ni dia akan menghasilkan satu persamaan kedua. So daripada dua persamaan ni kita boleh gunakan matematik ke simultaneous equation ataupun keadaan gantian dan sebagainya untuk mencari nilai acceleration A. Okay, cuba macam mana. So the first object A, kita tengok yang objek A dulu kan, dia bergerak ke bawah. Semestinya daya bersih itu mesti ke bawah. Okay, so we have a T. Okay, T, daya ke bawah. Di samping itu juga, walaupun dia ditarik oleh tension T, dia juga ada daya berat. Maksud jasad ini, kalau tak ditarik pun dia akan jatuh. Ada daya ke sini ni. Saya tulis arrow kat sini ni. Ada force kat sini juga ni. Iaitu disebabkan ada kaitan dengan daya berat. Okey, kalau saya padam balik kat sini supaya nampak jelas. Okey, supaya dia punya gambar rajah tu lagi jelas. Sorry. Okey, saya lukis kat sini. Besar sikit. So weight force dia lurus W. So ini kita ada segitiga kat sini. Okey. Segitiga 90 degree. Force ini yang kita perlu nak kita nak cari daripada segitiga ini. Force ini berapa? Force ini ada kaitan dengan mg kat sini. Force mg weight force. Seperti biasa, ini 30 degree. So sini this is also 30 degree dan dia opposite sini adalah mg segitiga ni trigonometry. So mg opposite, so we have a sin 30. Dia ke bawah. Jadi ke bawah ni ada dua sorry. Sini kalau untuk yang free body diagram, yang ni kita tak perlu lukis kita tulis T saja. Tapi sebenarnya ada dua force kat sini untuk case ini So T ditarik juga ke bawah juga. Jadi kita perlu tambah sini mg sin 30. Dan untuk dia ke bawah, dia perlu atasi geseran. So, kita minus. Sorry, tak nampak kat sini saya tulis Okey, saya padam balik sini. So, T ke bawah tambah dengan dua-dua ke bawah mg sin 30 minus friction force ke atas iaitu 6 Newton dia sudah bagi kan, is equal to MA. Dia pecuk is equal to MA. So asalnya sini kan F is equal to MA. So cuma force daya bersih untuk arah ni adalah force kat sini inilah. Ni. Force kat sini. Yang ni. Right? So itu yang okay. Daripada sini kita boleh dapat M plus mass. Saya rasa dia bagi mass untuk yang A ni 4 kg time G 9.81 sin 30 minus 6 mass dia bagi untuk objek A adalah 4 time A. Jadi kalau kita kira kat sini T is equal to, this is sin 30 is half, sorry, sin 30 is half. So here we have a, sorry. So T plus, this is 2G minus 6 is equal to 4A. Let's say this is a first equation. Objek pertama menghasilkan persamaan pertama. So the second situation here produce second equation. So how you can find the second equation? So refer to the diagram B here. So we have a direction downward, meaning weak force is greater than tension T. Kerana dia bergerak ke bawah kan, jadi daya ke bawah lagi besar daya ke atas. So for the B here, this is for A. A for the B, objek B. So W, daya ke bawah tolak daya ke atas, W minus T, right? Okay, W minus T is equal to MA, right? Sorry. Saya padam sini tadi ya. This is for the object P. So W minus tension T is equal to MA, acceleration. Tapi itu for object B, this is weight force is a mg minus T here is T is equal to, for the object B, mass is a 1A. So here we have a mass 1. So this is G here, cos M1 kan tinggal G minus T is equal to A. So this is second equation. So kamu guna dua persamaan ini, you have two equations. So guna gantian mana-mana mungkin gantikan G ni dalam persamaan, no, the G here because G is constant, sorry. So tahu sudah kan, this is 9.81. So guna mana-mana persamaan 2 dalam satu sini, kita minus persamaan 2 tolak dengan persamaan tambah persamaan 1 tambah dengan persamaan 2. Saya tulis kat sini Alright. So kalau kita ambil first equation plus second equation, so you can find the value of the A here. So we have a G here, what G minus acceleration 2A. Here we have a 4, and this is a, simple, this is not a mathematics calculation here. So we have okay, saya pemudahkan kat sini dua persamaan sini. So we have 5A is equal to, okay, ganti ataupun tambah boleh 5A is equal to 3G minus 6, and you can find the value of, because G is constant 9.81, so you can find the value acceleration is equal to 4.69. Right, guna dua persamaan ini, kamu akan dapat. Okay, okay. So soalan yang kedua, kita dah jawab soalan yang pertama, kita pergi kepada soalan yang kedua. Tension. Jadi untuk tension tadi, kabel tu kita boleh apa? Because kita boleh guna, katalah kamu ambil yang first part ini. First part ini kita ada weak force and T ke atas kan. So bergerak ke bawah, W minus T. Sama persamaan tadi is equal to M A. Tapi A tadi kamu dah kira tadi, saya tengok berapa A tadi, kalau lupa. A tadi 4.69 saya rasa. Okay. So W for the object A is mg. Mg M is equal to 1 kilogram, G is a 9.81, and the mass is equal to 1, so you can find the value of the tension. So if you use the calculator here, 9.81 here, 1.69. So we have a value of the tension here is negative 5.19. So negative here is refer to the direction to the tension, this opposite direction. This is opposite direction to the weak force value. So the magnitude, because the question asks you to calculate the magnitude of the tension is 5.12 Newton. Okay, class. This is number 8. So we have another 2 questions. Let's continue. This is almost 1 hour 30 minutes. Okay, tidak apa, kita teruskan sikit lagi ya. Okay, class. Question number 9. So block A and B here, mass 3.5 for A and 2 kilogram for the object B, are connected with a light string across the smooth Pulley as shown in figure. And the T, when the T is equal to 0, block A is puller 30 Newton, force 30 Newton force, direction to the upward, and moving object to the left. Coefficient kinetic friction of block A here is 20. So because the object A moving to the left, so meaning this is direction of the friction. So acceleration for the both of the block. So acceleration here, because object A pull to the force 30 Newton, meaning direction object A to the left, and friction force direction to the right, and we have a weak force downward. So we have a normal force upward. Here, because direction of the object or acceleration to the upward, this is acceleration to the left, right? So we have a weak force here, W, and we have a tension direction to the upward. So if the question asks you to draw the free body diagram for the object A, free body diagram, object A, we have how many force? We have 1, 2, 3, 4. We have the external force F. We have the weak force direction straight to downward, and we have the normal force straight to the upward, and we have a friction force. But also we have the tension of the string because connected to the string here. So because the direction of the object to the left, so tension is to the right, right? So we have also we have a tension of the string T, right? Okay, class. So now the question asks you to calculate the acceleration of the block. So acceleration here is also the same value of acceleration here. Both of object A and B have the same value of the acceleration. So now, seperti yang kalian tengok nombor 8 tadi kan, kita ada 2 blok. Biasanya first block dia akan produce satu persamaan, the second block produce the persamaan kedua. So yang senang kalau kita tengok persamaan B dulu kan, objek B dulu. So objek B, macam mana kita boleh produce persamaan? Because direction object to upward, so meaning upward force greater than downward force. Daya ke atas lebih besar daripada daya ke bawah. So here we have a T, this is for object B, T minus weak force is equal to mg for the object B, this is for the object B, minus m object B G is equal to 0. Ya, sudah kita hasilkan persamaan pertama. Okey, persamaan kedua hasil daripada objek yang kedua. Semua objek kedua ni agak complicated sedikit because first kita ada banyak kan. Kalau tengok dekat free body diagram, how many force? 1, 2, 3, 4, 5. So setiap satu ni kita kena consider kan. So untuk mencari dia bergerak ke arah kanan, so meaning we have a net force ini. So macam mana nak cari net force? Kita kena tolak semua daya-daya ke arah kiri. So cuma kat sini external force ya 30 Newton, dia tidak segaris berada pada paksi. X kita kena resolve, kita guna segitiga ni untuk kat sini kan, resolve F ini kepada arah X. So seperti biasa segitiga tu, this is adjacent, so we have a F cos 30, okay, minus T, right? Minus T is equal to, because we have another friction kat sini. Friction force kan, friction force baru dah bergerak dengan Ini untuk jasa A, MA, baru dia bergerak dengan acceleration. A kat sini sama dengan, sorry, this is not is equal to 0. Sorry, this is equal to MA because dia ada acceleration kan. A kat sini, this is mass untuk A, sorry, untuk B. Sama dengan acceleration kat sini. T kat sini pun dia sama dengan T di sini. So this is the second equation. Cuma kat sini kalau kamu tengok ya, dalam kes ini dia tidak bagi dia punya frictional force. Dia tak bagi frictional force terus, dia bagi cuma coefficient. Jadi kamu perlu cari frictional force dulu kat sini. Untuk mencari frictional force macam biasa, rumus dia adalah nu n. Tetapi nu dia sudah bagi. Nu tak ada masalah, this is 0.02. So problem ni adalah normal force. Normal force kat sini berapa kita nak cari. So normal force sama juga dalam pengiraan yang kita dah buat tadi. Untuk cari normal force, kita consider daya pada paksi Y. So kita ada N, kita ada W dan kita ada satu lagi sini, segitiga kat sini ni, kita ada ni, force ini dia menghasilkan Fy juga ni. Jadi ada 1, 2, 3. 2 Fy dengan T ke atas, W ke bawah. Tapi dia tak bergerak, maksudnya daya ke atas sama daya ke bawah. Daya ke atas kita ada apa? Daya ke atas, this is Y, arah Y. Daya ke atas adalah Fy. Tapi kita terus boleh ambil kat sini lah, because pakai segitiga ni, because opposite kat sini kan, opposite. So saya terus lukis kat sini. Kat sini saya ambil apa? Fy sini adalah F sin 30. Okay. Dan N pun sama arah dengan Fy, so plus N. Tapi ada lagi satu daya arah Y tapi ke bawah, that's why kita minus W is equal to 0. Mengapa is equal to 0? Because dia tidak bergerak ke arah Y, dia cuma gerak pada arah X sahaja. Jadi kat sini kamu kena gantikan, tunjuk force kat sini 30 and W is equal to, object here is W is equal to mg. So mass here adalah mass for object A is 3.5. 3.5. G dia adalah time 9.81. Alright. Okay. So daripada sini kamu akan dapat dia punya nilai N. Right. Ataupun kamu boleh masuk nilai N ini ke dalam sini. Right. Masukkan dalam sini. So kalau kita guna kalkulator, N is 30 sin 30. Okay. N masukkan kat sini. 91 minus 30. Okay. Sin 30 half. 3.5. 3.5 times 9.81. Okay, times 0.2 here. So Fk here, saya tulis lagi sini frictional force Fk here is equal to 3.86 Newton. Dah dapat yang ini, barulah kembali balik kepada persamaan sini ni, masuk ganti Fk kat sini. 3.86 ni. Okay. So masukkan kat situ. Kamu ganti balik apa yang kita sudah tahu kat sini. Force kat sini 30. Tension tak apa. Ni Fk kita dah tahu 386. Mass untuk objek A berapa? 3.5. 3.5. So kalau kita ringkaskan persamaan ni, dia akan jadi apa? Untuk ini dia akan jadi, this is time, cos this is new K, pindah sini. So tak, kamu akan dapat sini apa? T minus T kita dapat A kat sini, this is 22.12 minus T is equal to 3.5A. Right? Ini persamaan kedua. Persamaan pertama ni saya rasa kita boleh gantikan, this is T minus mass B is 2 2 kilogram. Okay, 2 times 9.81, this is a 19.62 is equal to mass B 2A, right? 2A. This is 2A. This is first equation. Saya dah tukar, gantikan ya. So, kamu sudah ada kat sini. Ni nampak lebih senang. Kita dah ada dua persamaan kat sini. Boleh guna kaedah gantian ataupun kamu ambil saja persamaan pertama tolak dengan persamaan kedua. This is plus, this is negative, so cancel T. So kamu akan dapat calculation here, the final answer for acceleration. So use the calculator, and the final answer for the A is equal to 0. A is equal to 0.45 meter per second square, right? Acceleration. And number next is a time taken for, tak nampak sini Okay, saya boleh padam dulu sini Right. Okay. Time taken for block B to move up 1 meter. Okay, maksudnya kat sini jasad ini dia akan bergerak pada acceleration yang ni bergerak ke atas acceleration ni 0.5. Tapi dia kata pada ketinggian pada jarak 1 meter. Berapakah time take? Ni maksudnya kamu guna balik linear motion equation untuk mencari nilai T So yang ni kita guna persamaan S is equal to UT plus half AT square. Mengapa kita guna rumus yang ini? Kerana S dia bagi berapa sini? 1 meter. Initial U because objek ni bermula daripada dalam at the rest okay. Bermula daripada dia tak bergerak kan? Bila ditarik maksudnya baru akan bergerak. So meaning here this is a U is equal to 0. So this is equal to 0. And the acceleration kamu dah kira tadi kat sini 0.45. And you can find the value of the T here. So if you calculate the value of the T, so I write here that T is equal to 2.1 second. Okay, kelas agak panjang lebar terabur kat sini, tak apa, nanti kamu dapat idea tu, at least nanti kamu boleh kira balik secara lebih teratur lah. Dalam exam kamu jangan tulis macam ni hilang markah kamu nanti. Okay, class, so continue to next question. I think this last question and now question number 10, right? Okay, question number 10. Yeah, last question number 10. Okay. Sekali lagi class. So the third Newton law. Tadi awal-awal tadi pun kita dah bincang mengenai Newton law. We have 3 Newton law, first, second and third Newton law. For the third Newton law, kita tahu every action force has a reaction. So maksudnya kalau satu jasad itu dia berikan daripada satu A kepada B, dia akan reaction dia B kepada A itu dia akan balas balik, tapi pada arah bertentangan. Action and reaction. Every action force has a reaction. The force is equal but magnitude opposite direction. That's why we use a negative sign here. This is a third Newton law. And the second 10B, okay, we have 2 blocks, A and B, mass 10 kilogram and mass 30 kilogram. This is 10 kg and this is 30 kg, right? And and contact each other. They are pushed along the smooth floors, meaning we consider the no friction force, smooth floor under action constant force. So ditolak dengan satu daya force kat sini. The force here magnitude is 200 Newton. Okay, calculate acceleration of the block. Because the force acts on the both object and AB, and object A and B moving with the same velocity or acceleration for the object B and object A is the same value, right? For the object A, same magnitude for the acceleration for the object B. So now we can find the, okay, look at the second Newton law. So we have a F is equal to MA. Now the force, external force here is 200, and the mass is both of mass here is 10 plus 30. This is 40 kilogram, and you can find the acceleration here is 200 divided by 40 is equal to 5 meter per second. This is acceleration for the object A and object P. So number 2, the force exerted by A on B. Ya, bila kita tolak dengan 200 Newton force, external force, B ni akan kenakan daya kepada A akan kenakan daya kepada B. So now the force exerted A on B, right? So now here, because the object here, object 10 kilogram, X on the object B, the force AB, but AB apa ni, touch each other, dia bersentuh, B akan balas balik kan, third Newton law dengan daya yang sama iaitu FBA, tapi negatif, tapi FAB is equal to FBA, cuma arah saja bertentangan. Jadi kita tolak 200 Newton ke atas A tolak B, sebelum B terbergerak dia akan balas balik BA. Tapi jikalau AB tak sama dengan BA, kemungkinan jasad ni tak bergerak. Kamu kena tolak lagi kuat force. Tapi dalam kes ini sudah bergerak. Maksudnya sudah ada acceleration yang kita kira tadi 5 meter per second ke arah kanan. Jadi mesti akan ada daya bersih. So what is the daya bersih? Maksudnya daya yang dikenakan AB lagi besar daripada daya yang dikenakan A ke atas B lagi besar tolak dengan daya yang B bagi balik kepada A akan menghasilkan S daya bersih F net, okay, ataupun is equal to MA. So this is the idea dia. Ni saya bawa letak sini So dalam kes ini dia mau cari apa? Okay, saya potong sini dulu potong sini dulu. Dalam kes ini FAB daya yang dikenakan, because kita tolak objek A ni 200 Newton. So 200 Newton. Jadi daya ni akan dikenakan kepada B. Jadi FBA. Okay. Is equal to, dia akan bergerak dengan apa? Okay. Mass ini apa? Yang menyebabkan apa? Yang menyebabkan, ni kita merujuk because dia tanya A ya. Objek A ni, A on B, maksudnya kita fokus kepada mass A lah, because A kepada B. So maksudnya mass A adalah 10. Acceleration kita dah kira awal tadi, dapat 5 kan. Semua objek ni bergerak pada 5 meter per second. So this is 5. So now FBA, kamu akan dapat, this is negative So remember, so here we have this is here this is 200 is greater than 10 times 5. So here we have a positive 150 Newton. Okay, so dalam keadaan macam ni, maksudnya apa dia? Because jasad ini kalau ikut third Newton law, daya yang diberi, kita balik kepada tadi, sini Okay, FBA kita dapat tadi sini berapa? Kita dapat sini 150. So sama juga dengan FAB juga kita dapat 150, daya yang sama. Jadi the force exerted by object A to the object P on object B is 150 Newton. So class, almost 2 hours, 50 minutes before sekarang ni 3:46. So tidak apa, jadi kita sudah habis Macam mana? Saya bagi sini cuma idea je. Saya bagi the idea saja. Because secara calculation tu pun saya agak cepat sedikit je kot. The idea. And next, kamu kena buat sekali lagi. Mungkin kamu ada cara lain yang lebih senang. Teruskan. Cuma kalau boleh pakai idea saya ataupun cara saya selesaikan. Kalau kamu ada cara sendiri pun tak ada masalah. Okay? Cuma kat sini, saya bagi cadangan jawapan saja. Ikut kefahaman saya. So, class, thank you. That's all. Okay, kita jumpa lagi pada sesi-sesi akan datang. Sekian, terima kasih. Assalamualaikum dan salam sejahtera. Bye-bye.